Hello my dear students, in this class I will teach you electric field. Okay, so for this, suppose we have a positive source at point O. Suppose this is our point O, and at point O the plus Q source is there. Okay, this is a point O, and at this point there is a source of magnitude plus Q. Okay, and this plus Q source will exert a force upon other surfaces, and the distance, or you can say and the region up to which it can exert force is known as the electric field of that source. Okay, suppose this is the region up to which it can exert some appreciable amount of force, and that region is known as the electric field of that source. This is what? This is the electric field of this source. Okay, if the magnitude of source is large, suppose this is our this plus Q is our 4 microcoulomb. Okay, and this is the field of this 4 microcoulomb source. If the magnitude of the source is large, that means if we consider 10 microcoulomb source, then the field will be larger compared to 4 microcoulomb, because the field means the region, the surrounding the surfaces up to which it can exert some appreciable amount of force. Okay, the field of this surface is up to that distance up to which it can exert some appreciable amount of force. If suppose this is our positive, if positive another positive charge is there, then this charge will repel this charge, and if negative charge is there inside the field, this source charge will attract this negative charge. If another positive charge is outside the field, then it will don't repel these charges, because this charge is outside the field. That is why it has no influence on these charges. Okay, the influence of the charge is only inside the electric field. That means electric field of a charge means the region up to which it can exert some forces. Okay, so if the magnitude of the charge is large, the field will be also large. That means it will exert the force up to large distance. If the magnitude of the charge is small, then the field of the charge will also be small. Suppose this is the field of charge plus 4 microcoulomb. If we consider a charge of 0.1 microcoulomb, then the field will be very small. If you consider a charge of 0.01 microcoulomb, then the field will be very small. Okay, that means if you consider small charges, the small magnitude of charges, the field of that charge, field means the region up to which it can exert force, will be very small. Okay, for a test charge, what is test charge? Test charge means whose magnitude is almost tends to 0. Test charge means a charge whose magnitude is very small. Okay, almost equal to 0, and the field of the test charge is like a point only. ये जो टेस्ट चार्ज का जो फील्ड है वो ओनली पॉइंट ही होगा, यानी इसका जो मैग्नीट्यूड है वो वेरी स्मॉल टेंड्स टू 0. Okay, electric field is what? Electric field is a region up to which a source charge can exert some appreciable amount of force. Okay, then we define another term, and the term is electric field strength. Electric field strength, or you can say electric field intensity. Or you can say electric field also. Okay, Suppose this is the region of this is, we have considered a positive charge, we have considered a positive charge plus q, and this is the region up to which it can exert some appreciable amount of force, and this region is known as electric field of these charges. Okay, now we define the term what is electric field strength or electric field intensity, or it is known as electric field also. Okay, electric field strength is different at different point inside the field. Electric field strength means the force upon a unit test charge. The force upon a unit test charge. If you take a test charge at this point, at a distance suppose 5 centimeter, if you take a test charge q naught, okay, and if you take another test charge at a distance 10 centimeter, okay, the force will be stronger at 5 centimeter compared to force on 10 centimeter, because this q naught test charge is closer than this q naught charges. Okay, that means if you take another test charge near to the source charges, the force will be very strong. Okay, that means the electric field strength at this point will be stronger than this point. That means if you come close to the source charge, the electric field strength will be more stronger. That means you can say at different point the electric field strength are different. The electric field strength are different, because electric field strength means what? Electric field strength means the force upon a unit test charge. Force upon a unit test charge. Okay, electric field strength, numerically it will be equal to your electric field strength, or it is denoted by E, is equal to force upon a limit q naught tends to 0, force upon a unit test charge. Here I am taking limit q naught tends to 0 because it is a test charge. Test charge means the magnitude is very small. Here the q naught is a very small, that is why it is known as the test charge. Okay, ये जो टेस्ट चार्ज रिप्रेजेंट करने के लिए हमको ये लिमिट q नॉट टेंस टू 0 लेना पड़ता है. अगर इसको हम डायरेक्टली ऐसे लिखते E इज इक्वल टू व्हाट f डिवाइडेड बाय q नॉट. ओके, तो ये जो चार्ज है ये तो बड़ा भी हो सकता है. अगर हम इसको ऐसे लिखेंगे लिमिट q नॉट टेंस टू 0, दैट मीन्स ये जो q नॉट का जो मैग्नीट्यूड है इट इज वेरी स्मॉल, टेंस टू 0. दैट इज वाई ये एक्चुअली क्या रिप्रेजेंट करता है? दिस लिमिट q नॉट टेंस टू 0 विल रिप्रेजेंट एज q नॉट एज ए टेस्ट चार्ज. ये जो q नॉट है इसको ये जो लिमिट q नॉट टेंस टू 0 इट विल रिप्रेजेंट q नॉट एज ए टेस्ट चार्ज. टेस्ट चार्ज मीन्स उस मैग्नीट्यूड इज वेरी स्मॉल, वेरी स्मॉल. ओके, दिस इज द, or simply you can write E is equal to f by q naught also. What is E? E is the electric field strength, or you can say electric field intensity, or simply you can say electric field. Electric field strength at any point inside the field is the force exerted upon a unit test charge. Okay, so you remember what is electric field intensity or electric field strength. Electric field strength at any point inside the field is the force acting on an unit test charge. Is the force acting on a unit test charge. That is the electric field intensity. Sometimes it is called electric field strength also, or sometimes it is called electric field also. Okay, so remember what is electric field? Electric field means force exerted upon a unit test charge inside a field. Okay, it is very simple. What is electric field? Electric field means it is force. Okay, force upon a unit test charge upon that point. At different point you can see at different point the electric field strength will be different. If I consider this point, what is the, suppose this is our point P. At point P, what is the value of electric field? What is the value of electric field? The value of electric field at this point, okay, is the force acting upon a unit test charge. इस पॉइंट पर एक यूनिट टेस्ट चार्ज के ऊपर जितना फोर्स लगेगा वही होगा इस पॉइंट में इलेक्ट्रिक फील्ड का वैल्यू. ओके, इलेक्ट्रिक फील्ड मीन्स व्हाट? इट इज द फोर्स एक्टिंग ऑन ए यूनिट टेस्ट चार्ज एट डिफरेंट पॉइंट. At that point, okay, and the force will be different at different point because force is equal to what? Force is direct inversely proportional to distance. If distance is increases, the force will be small. If distance is small, the force will be large. At different point, the force are different. Okay, so electric field is very simple. It is the electric field means force. Electric field means force acting on a unit test charge. What is the SI unit of this electric field? Okay, SI unit of electric field is SI unit of electric field is Newton per coulomb. Newton per coulomb. And dimension of electric field is how much? Dimension of electric field. Dimension of force is how much? mLt to the power minus 2, and dimension of charge is equal to your A into T, so it will be your mLt to the power minus 3 A inverse. So this is the dimension of electric field. Okay, I will again repeat. Electric field strength or electric field intensity is the force acting on a test charge. Test charge means whose magnitude is very small. Actually, this is the numerically this is the clear definition of electric field. This is the proper definition of electric field. Electric field means what? Force upon a test charge. Okay, so here I am writing limit q naught tends to 0. इसका मीनिंग क्या है? ये जो q naught का जो वैल्यू है इसका वैल्यू वेरी स्मॉल टेंस टू 0. दैट इज व्हाई वी हैव रिटेन दिस लाइन लिमिट q naught टेंस टू 0. और यू ऐसे भी लिख सकते हो E is equal to what? F by q naught. But remember q naught is a test charge. Test charge means whose magnitude is very small, very small. Okay, so electric field upon a electric field at any point is the force exerted upon a test charge. Okay, then we will discuss the electric field due to a point charge. Electric field due to a point charge. Okay, electric field due to a point charge. Okay, so this is our point charge at origin. O is the origin. This plus q, this is a point charge, or you can say source charge also. Source charge also. Source charge. Okay, and from this charge at a distance r, p is another point. At a distance r, P is another point, and at point P we need to calculate the strength of electric field due to this source charge, or you can say we need to calculate the electric field intensity at point P due to this source charge, or you can say also we need to calculate the electric field at point P due to this source charge. Okay, for this, what is electric field or electric field strength? It is the force acting upon a unit test charge. It is what? Force acting upon a unit test charge. That is why we have to take a unit test charge q naught at point P. For this, we have to take a unit test charge at point P, and what will be the force on that test charge due to this source charge? Remember, q naught is test charge. ये जो q naught है ये है टेस्ट चार्ज. ओके, एंड द फोर्स एक्सर्टेड अपॉन दैट टेस्ट चार्ज विल बी हाउ मच अकॉर्डिंग टू कूलम्ब्स लॉ. अकॉर्डिंग टू कूलम्ब्स लॉ, what is the force exerted upon that test charge? The force exerted upon the test charge will be equal to your 1 by 4 pi epsilon naught q naught by r square. If you want to write in vector form, then it will be your r cap. R cap is a unit vector in the direction from q to q naught. Okay, that means this source charge will repel this Q naught in this direction with a force F. Okay, our aim is we are going to calculate the electric field at point P due to this point charge, or you can say source charge. Okay, for this purpose we have taken a test charge at point P. Okay, test charge means whose magnitude is very small, it is always positive, and according to Coulomb's law, the force exerted upon that test charge will be how much? 1 by 4 pi epsilon naught Q naught by R square R cap. Okay, then according to definition, by definition of electric field, इलेक्ट्रिक फील्ड का जो डेफिनेशन है वो क्या है? इलेक्ट्रिक फील्ड E is equal to what? The force exerted upon a test charge divided, it is what? Force exerted upon a test charge, that means F divided by Q naught. Okay, so what is F here? In place of F, what we can write? 1 by 4 pi epsilon naught Q naught by R square R cap divided by Q naught. Okay, so Q naught will go cancel. Therefore, the electric field due to the point charge will be equal to how much? 1 by 4 pi epsilon naught Q by R square R cap. Okay, so this is the electric field. Electric field is equal to how much? 1 by 4 pi epsilon naught Q by R square R cap. R cap means the direction of the force. So from this, इससे हमने क्या देखा है? ये जो फोर्स का जो डायरेक्शन है, द डायरेक्शन ऑफ फोर्स और जो डायरेक्शन ऑफ फील्ड बोथ आर सेम. डायरेक्शन ऑफ फोर्स और डायरेक्शन ऑफ फील्ड दोनों क्या है? दोनों सेम है. जिस डायरेक्शन में ये तेज चार्ज को रिपेल करेगा उसी डायरेक्शन में फील्ड का भी डायरेक्शन होगा. ओके, यू रिमेंबर द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड एंड डायरेक्शन ऑफ फोर्स बोथ आर सेम. Okay, both are in the same direction, and the magnitude of the field will be equal to what? How much? 1 by 4 pi epsilon naught Q by R square. Okay, this is the magnitude of the field, which is equal to 1 by 4 pi epsilon naught Q by R square. Okay, this is the electric field due to a point charge at a distance R. Okay, suppose if we have a point, suppose this is a point charge Q. Okay, at a distance R. At a distance R1, this is another point. At this point, what is the value of electric field due to this charge? Due to this charge, the electric field at this point will be how much? U1. Suppose U1 will be equal to 1 by 4 pi epsilon naught Q by R1 square. If you take another point, this is another point Q at the distance R2, what will be the value of electric field at this point? The value of electric field at this point will be equal to your 1 by 4 pi epsilon naught Q divided by R2 square. That means the electric field due to a point charge at a distance R1 is this one, 1 by 4 pi epsilon naught Q by R1 square, and at a distance R2, the magnitude of electric field will be how much? 1 by 4 pi epsilon naught Q by R square. Okay, so this is the electric field due to a point charges. Then we will discuss the electric field due to multiple charges. Electric field due to multiple charges. Electric field due to multiple charges. Okay, suppose this is charge Q1 and this is another charge Q2 and this is charge Q3. These are the 3 point charges, and due to these 3 charges we need to calculate the electric field at this point P. Okay, P is another point. P is a point. At point P we need to calculate the electric field due to these 3 charges. Okay, we need to calculate the electric field at point P due to these 3 point charges. Okay, for this let us consider we need to take a test charge Q naught at this point. We need to take a test charge Q naught at this point. Okay, the Q1 will repel this test charge in these directions. Okay, so what is our aim? We are going to calculate electric field at point P due to these three charges. Okay, पहले ये देखो, अगर P पॉइंट में इलेक्ट्रिक फील्ड निकालना है तो P पॉइंट में हमको क्या लेना होगा? एक टेस्ट चार्ज Q नॉट लेना होगा, बिकॉज इलेक्ट्रिक फील्ड मीन्स व्हाट? इलेक्ट्रिक फील्ड मीन्स फोर्स अपॉन ए यूनिट टेस्ट चार्ज। एक यूनिट टेस्ट चार्ज के ऊपर कितना फोर्स लागू होता है वही होता है इलेक्ट्रिक फील्ड। दैट इज व्हाई वी हैव टू टेक ए टेस्ट चार्ज एट पॉइंट P। ओके, Q1, Q2, Q3 all are positive and this test charge is also positive. Okay, this Q1 will repel Q naught in this direction with a force F1P, with a force F1P. And what is that force? The force F1P, that means force on charge Q naught due to Q1 will be equal to your K. K is in place of 1 by 4 pi epsilon naught, we can write K also, K Q naught Q1 by R1P square. R1P is the distance from Q1 to Q naught. What is R1P? R1P is the distance from Q1 to Q naught. Okay, this is the force exerted upon charge Q naught due to Q1. If this is the force, what is the electric field at that point? Electric field E1 is equal to your F1P divided by Q naught. F1P means force on charge Q naught due to Q1, which will be equal to, in place of F1P, what we can write? K Q naught Q1 by R1P squared divided by Q naught. So Q naught will go cancel. So electric field at point P due to such Q1 will be how much? K Q1 by R1P squared. Okay, so direction of force and direction of electric field will be same. So in place of force we can write electric field. So electric field is E1 is how much? K Q1 by R1P square. If you want to write in vector form, it will be R1P cap. What is R1P cap? It is the unit vector. It is a unit vector in the direction Q1 to Q naught. Okay, E1 is the electric field at point P due to charge Q1. Q1 के कारण इस पॉइंट पर इलेक्ट्रिक फील्ड का ये है वैल्यू K Q1 by R1P square R1P cap. At the same time, the charge Q2, this charge is also positive. This will repel this test charge. Okay, this is our test charge. At the same time, the charge Q2 will also repel Q naught in this direction. That is why electric field due to charge Q2 will be equal to your E2. E2 is what? Electric field due to charge Q2, which will be equal to your E2 will be equal to your K Q2 by R2P square. What is R2P? The distance from Q2 to Q naught. R2P. Distance from Q2 to Q naught. Okay, R2P square R2P cap. Okay, and at the point P, this E1 is the electric field due to charge Q1 and E2 is the electric field due to charge Q3. What will be the resultant electric field? Electric field is a vector quantity. E1 and E2 both are vector quantity, and the resultant and both vectors are acting at a single point. Their tails are at a single point. That is why with the help of parallelogram law we can determine the resultant vector. We can determine this is the resultant vector E1 plus E2. E1 plus E2. Okay. At the same time, the Q3 also repel. The charge Q3 also repel Q naught in this direction. The charge Q3 is also repel. The Q3 is also repel Q naught in this direction. That is why electric field due to charge electric field due to such Q3 will be in this direction. What is the magnitude of Q3? E3, the electric field E3 is equal to your KQ3 by R3P square. That means the distance is your R3P. R3P square, R3P cap. Okay. At point P, electric field due to charge Q3 will be equal to your this one. Okay. What is the resultant? Okay. Here E3 and E1 plus E2. This is what? E1 plus E2 is the resultant of E1 and E2. Okay. And these two vectors, this E1 plus E2 is the resultant of E1 and E2. And this is a single vector now. Okay. This is the resultant of these two vectors. And E3 is another vectors. What will be the resultant of this and this? For this, these two vectors are also acting at a single point. That is why we have to use the parallelogram law. If you complete this parallelogram, okay, this will be the resultant, E1 plus E2 plus E3. E1 plus E2 plus E3. This is the resultant. That means the resultant force acting, the resultant electric field at point will be along this direction. Okay. That means if you want to write the electric field at point P, or at point P is equal to what? The electric field at point P is the vector sum of all the four electric field, E1 plus E2 plus E3. Okay. In place of E1, what we can write? KQ1 by R1P square, R1P cap. What is E2? KQ2 by R2P square, R2P cap. E3 is equal to your KQ3 by R3P square, R3P cap. Okay. The resultant field, that means EP is the resultant electric field at this point. EP is what? The resultant electric field due to these three charges. Okay. Here we can take K, means K we can take common, then it will be summation of I is equal to 1 to N, or Qi RIP square RIP cap. So this is the resultant electric field at point P. If you put I is equal to 1, then you will find the first term. If you put I is equal to 2, then you get the second term. Okay, in this way, this is the total electric field at point P. Okay. This is the total electric field at point P. Okay. So what is electric field? Electric field means the force on a unit test charge inside the field. Okay. You remember, electric field is the force upon a unit test charge inside the electric field. Okay. And we have already calculated the electric field due to a point charges. Electric field due to a point charge will be how much? Electric field due to a point charge. Suppose this is our point charge Q, and at a distance R, suppose P is any point at point P, the magnitude of electric field due to this charge will be how much? 1 by 4 pi epsilon naught Q by R square. It's very simple. Okay, in next class we will discuss some numericals related to electric field and for multiple charges.